This is section 3.2, part A, logarithmic functions. Your I can statements for this half of the section. I can evaluate expressions involving logarithms. So a logarithmic function with base b is the inverse of the function f of x is equal to b to the x, which is denoted log base b of x. So if you think back to section 3.1, the very last example we worked on, we were trying to figure out what year our value would drop below 20,000 for the chickenpox cases. Now we couldn't solve this because our variable was in the exponent and we didn't know how to get it out of the exponent yet. But using logarithms lets you solve for x for these cases without just having to graph and guess and get to the closest value. To solve them, we are going to use the inverse, which is the log functions. So log base b of x is the inverse of your original function or your exponential function. So if we see them in the exponential form and the logarithmic form, if it's in the exponential, your base is your b, your exponent is y, and we're going to set that equal to x. Okay, that's what we're going to try to find. So if we write this in a logarithmic form, it's the log base b of x is equal to y. And then we can solve for the exponent. So we're going to evaluate each one of these functions. So remember, this is your base or your b value. This is your x, and we're going to set that equal to y. Now right now we don't know how to find log base 3 of 81, but we can write this in exponential form. Exponential is by is equal to x. So our b value in this case is 3, and our x value is 81. So we want to find a value of y, so that 3 raised to the y is equal to 81. Now for now we're just going to plug these into our calculator and try them until we find one that works. So 3 to the first power is 1, 3 to the second is 9, 3 to the third is 27, but 3 to the fourth is 81. So our y value is going to be 4. We do the same thing on the next one. Remember, this value is your b, this is your x, and it's equal to y. When we write it in exponential form, we have b to the y is equal to x. Now remember, the square root of 5 is the same thing as taking 5 to the 1/2 power. It's a square root, so it's a second root, or it's equivalent to 1/2. And so in this case, since the bases are the same, our exponents must be equal, so y is just equal to 1/2. On the last one again, this is your b value. This is your x. We set it equal to y. So b to the y power is equal to x. Now 49 is the same thing as saying 1 over 7 squared. And to get that out of the denominator, to move up to the numerator, you just take your exponent and you make it negative. So in this case, y is going to equal -2. Now there are some basic properties of logarithms. If your base is greater than 0 and your base does not equal 1, then we can use these following rules. If you have the log base b of 1, it's always going to equal 0. That's because if we rewrite this, this would be b to the 0 is equal to what value? It's always going to equal 1, because anything raised to the 0 power is 1. We know that log base b of b is 1, because if you rewrite this as exponential, b to the first is just equal to b. If we have log base b of b to the x, that's just equal to x. Again, if we write this in exponential, this would be b to the x is equal to b to the x. And if you have b raised to the log base b of x, that's just equal to x. That's because this base is going to cancel the base of your log, and you're just left with your x is equal to x. So if we use that information, if we have a log base 5, we want to see if we can get that number so that it's also 5, but it's raised to a certain power. Now 125 is actually 5 to the third power, so we can rewrite this. Now if we look at our previous rules, if you have your base raised to the log of the base, or if you have log of that base is equal to, so if you have log base b of b, ours is log base 5 of 5, is raised to the third power, these are going to cancel, and you're just left with whatever your exponent was. So our log base 5 of 5 raised to the third power, the log base 5 and the 5 will cancel, and we'll just be left with 3. Now in the next one, we don't have to simplify it. We just have 12 raised to the log base 12. The big base of 12 and the log base of 12 will cancel, and you will just be left with 4.7. The common logarithm is a logarithm that has a base of 10, or we call that log base 10, and it's often written without the base. So if you look at your calculator and you just see the button that says log, that's just the abbreviated version of the common logarithm, log base 10. It's just understood that the 10 is attached to it. So y is equal to log of x is the inverse of the exponential function. Y is equal to 10 to the x power. We still have those same rules, basic properties of common logarithms. If we do log base 10 of 1, that's still equal to 0. Log of 10 is 1 because it's a base of 10. Log 10 of raised to the x is equal to x because the base 10 that's not written cancels out with that large 10. And 10 raised to the log of x is equal to x. Again, you have to remember that log has a little base of 10, and so that's why they can cancel. So on the first one, we need to rewrite this so that it is in tens, because this is a log base 10. To make this a 10, we would need to move the decimal place. Okay, so if we move the decimal place, this is equivalent to 10 to the negative third power. Because this is a little base 10, those are going to cancel, and we're just left with negative 3. On this one, remember, this has a little base 10 attached, so these are going to cancel, and we're left with 5. Now, if it tells you to find the log of a specific number and the 10 is not involved, because we do have this on our calculator, you can just plug it into your calculator, and you can hit the log button and hit 26, and this will give you an approximate value of 1.42. If we have log of negative 5, again, this is log base 10, so you can put it on your calculator, but we cannot find a log of a negative value, so this one will be undefined. The natural logarithm is a logarithm with a base of e, so this is the inverse of an exponential that has an e to the x power. And this is denoted L of n. Okay, so if you see ln of x, this is the same thing as saying log base e of x. Ln is the inverse of base e. We still have those same basic properties. The ln of 1 is 0. The ln of e is 1. Ln of e to the x will just be x, and e raised to the ln of x will be x. So on the first one, we have ln of e. The ln and the e will cancel. And you will just be left with 0.73. The ln of -5, this is still a log, so you still cannot take the value of a log of a negative value. So this is undefined. E raised to the ln of 6. Again, the e and the ln will cancel. We'll just be left with 6. And if you need to find the ln of a value, you do have the natural log on your calculator. So if you type in ln of 4 on your calculator, it will tell you it's approximately 1.39.